Good evening to all our viewers here in India, and a good morning to friends across the oceans there, especially to our speaker today, Ravi Rajamani, who had to get up rather early to give this webinar today. As everyone knows, we've been doing this for a very long time now, over 2 years, and we've done 62, 63 webinars so far, all of which you can view on the IIT Alumni Center Bengaluru website. You'll find an interesting mix of topics, speakers, and moderators from all over the world who've kind of contributed to this very vibrant series. Today, I thought I'd do something different, and I spent a little time on ChatGPT, since ChatGPT is now the current hot favorite, and said, tell me something about electric propulsion. And within 5 seconds, I got a one-pager on electric propulsion. So that's the power of natural language processing for you now. So what ChatGPT tells me is that electric propulsion systems are made of several components, including electric motors, batteries, power electronics, and control systems. I'm trying to paraphrase that one page, and talks about some advantages, more efficient than traditional fossil fuel powered engines, higher efficiency ratings because electric motors have higher efficiency ratings, translating into lower fuel consumption and reduced emissions. So these are all what we see in the popular press. Another benefit, it says, is that it's quieter than traditional engines and more reliable and requires less maintenance. And then this talks about a few challenges. One major challenge is the limited range and endurance of current battery technology. So batteries are heavy and have limited energy storage capacity, which means that electric aircraft today have shorter ranges than their fossil fuel powered counterparts. But battery technology is kind of moving quite fast today. And it gives its own conclusion. It says, overall, electric propulsion is an exciting technology that has the potential to revolutionize aviation. So today's topic is on electric propulsion, and I think we have Ravi Rajamani, who's here, is probably the best in this business. His company is called Dr. R2. A little bit of the Star Wars connection there, I suppose. And he's also associated with the University of Connecticut. Lives in the Connecticut state, worked prior to his current job, worked at Meggitt, United Technologies, GE, and of course he's an IITian from IIT Delhi with a PhD from University of Minnesota. And he's written an interesting book, Electric Flight Technology, Unfolding of a New Future. I suspect his talk is going to be centered more around that book and what he's talked about in that book. So we're looking forward to that, Ravi. Moderating today is Dr. Padi, Dr. Radhakant Padi, who's the HAL Chair Professor in the Department of Aerospace Engineering at the Indian Institute of Science here. Dr. Padi had a busy day with the G20 delegation and just made it in time to join us today as the moderator. He has all the strings of accolades that you need to be in a faculty position in India: INAE, AESI, Aeronautical Society of India, Astronautical Society of India, IETE, IEEE, you name it. And I think he can put all those acronyms next to his name. And he's also got an interesting book on satellite formation flying, which uses probably a lot of electric propulsion. So we have two interesting speakers today. A few house rules: please put your questions in the Q&A box, not in the chat box. The chat box is not being monitored for any questions. So please do put your questions in the Q&A box. Second, just use the Q&A box, because even if you raise your hand, we don't have the capability to have an interactive session. It would not work well. So with those two things, I also want to introduce my colleague here, Dr. Sushila Venkatraman, who will sum up the webinar at the end of the 1.5 hours that we're going to spend talking to Ravi and Dr. Padi. Ravi, over to you.
Hey, can you hear me?
Yes, we can.
Thank you, Ashok. You basically stole my thunder. You and ChatGPT. I don't know what I'm going to talk about, but we will give it a good try. Okay, I'm going to talk about electric propulsion and give you a brief history of it, but and some of its technical challenges. More than anything else, I don't know if you have seen the Jetsons. It's obviously an American cartoon from way back when, and they had this personal flying machine for everybody there. I don't know how they did the propulsion there, but there are people within in America and elsewhere too who have been trying to figure this thing out. Let me show you a little video. So this is what people have been working on at one end of the spectrum. I'm only talking manned flight today. I'm not talking about drones, electric drones. There have been many such vehicles being developed all over the world, including in India. Manned is a little different. There have been some jetpacks. I know you've seen the ones, the French people in Dubai, and they've been trying that. Unfortunately, the lead pilot got killed a couple of years ago. So that's there have been some accidents, including with electric aircraft propulsion in China. There have been some real bad accidents. However, within the manned flight, there is at one end you have personal aircraft, and at the other end you have companies like Archer and Joby and Lilium, etc., that are developing personal. I'm sorry, they're developing passenger-oriented electric aircraft. So I got this recently. The leaders of the pack, according to at least this particular website, are there's a certified aircraft today by Pipistrel. It's not really based on anything very complicated. It's what they call the light sport aircraft. So it's not that difficult to get a certification in this category. The leaders within the more general aviation, what in FAA is called the Part 23 category, are Archer, according to this website, Joby, Lilium, Vertical. I would have put Whisk in that category as well. However, it is what their opinion is, and it's not that bad. The others, not necessarily in America. There's Volocopter in Germany, EHang, who say that they've already got a certification. However, some of my friends in FAA don't particularly believe in that. But in China, they've got, they say that they are certified. And then Beta Technologies, which is not that far from where I live, they're doing some interesting things with the Air Force here. So they're doing some good things within the OEMs, the major OEMs. Embraer has a program, and they're working with a couple of other companies to develop something called Eve. Airbus has plenty of programs. Boeing has bought Aurora Scientific and Whisk, and they are pouring in some money, but through these subsidiaries. Now, Dr. Padi knows I gave a talk maybe 3 years back at IISc on this. At that time, when I wrote this book, Airbus Siemens had just stopped working on the E-fan. They had moved that resources to what they call the A-Cube, a company they had set up in the Silicon Valley, and they were developing Vahana. which you and I know what that means. Volocopter was developing its, it was, I believe, called V3 or something. I don't remember. Zunum Aero was a company that was developing a hybrid aircraft in Seattle. Pipistrel was quite well. They had actually won a NASA program about 8 years back on electric flight. eGenius was the number 2, the runner-up in that flight. Unique in China, they had a couple of accidents, but they were quite active. There was a company called Itaipu Binacional in Brazil that was developing a electric aircraft, and then Leonardo, which was Augusta Westland, had a project of essentially a helicopter powered by electricity. Today, I believe only Volocopter and Pipistrel are left in that lot. Now, clearly Airbus is doing other things, and Zunum has gone out of business. Leonardo has teamed up with another company, I believe, to work on something. However, a lot of the programs we saw 5-6 years back are gone by the wayside. Why is this a problem? There are many hurdles to the adoption of electric propulsion. The aerospace industry is very mature in one way. It's extremely risk averse. It's very safety conscious. So system certification is a big deal for us. And electric propulsion brings in many new technologies, especially related to energy storage, reserve energy, the kind of control surfaces, the way you do the controls, etc., which brings up many technical issues. And that's one of the reasons why it is kind of tough. Also, a lot of these aircraft are transitional aircraft. In other words, they go from vertical flight to horizontal flight using propulsion systems that change their configuration. And that requires not only certification issues, but it also brings up operator certification problems. Pilots, there aren't civilian pilots who know how to fly these kind of hybrid aircraft. So the FAA is struggling with trying to get operator certification. There is process certification. In other words, these are all startups. They really don't know how to manufacture any of these things. So the FAA and I guess EASA and other regulators around the world require certification of the manufacturing processes, and that's a big deal. There are obviously constituent technologies that have challenges. I'll talk a little more about that. Electric grid issues. If everybody goes electric, how are you going to sustain that using the grid? Air traffic management. If there are going to be a lot of small aircraft flying around, maybe under 3,000 feet, above 3,000 feet for these larger ones, how's the air traffic going to be managed? That's something that NASA is looking deeply into. Regulations regarding vehicle operations. I mean, those of you who are working on automotive systems would know that this is a big deal. And with the regulations, with the operations comes automation as well. There is, though the two should be decoupled, electric and automation don't go together. However, in some sense, with these kind of new kind of aircraft, automation is becoming a sort of a complementary technology, and that has all kinds of issues, including for certification and risk. And risk averseness of passengers as well. I mean, do you really want to get into a aircraft which is so newfangled and technologically advanced? That's a question that I guess each one of us has to answer for ourselves. Well, when did it all start? Electric propulsion. Does anybody have a clue? I know this is not a question and answer kind of a thing, so I'll just bang right on to it. You won't believe it. 1883 is when the first aircraft with electric propulsion actually got off the ground. Of course, it got off the ground because it was lighter than air, but still, the point is that it had many of the elements that we see today in an all-electric aircraft. It had a battery, it had an electric motor, believe it or not, by Siemens. Siemens was there since that time. And it had a propeller that was designed by these brothers who flew this right outside Paris in 1883. It was reported in the US about 2 years later. They didn't have internet then. Some of the key milestones, I guess, in electric history, I don't want to belabor this too much, but rechargeable lead acid battery, 1859. There was Siemens, 1867, first AC alternator. And then you had obviously the motors themselves, which were used in this flight. So these things are fairly old. That was the only point I was trying to make. However, that was lighter than air. When was the first electric aircraft in modern time? That was in 1973, interestingly, also in October. A few years later than the first electric aircraft, lighter than air. This was a modified, I would say, a glider. That's what they call it, a motor glider in Vienna, in Austria. And this, believe it or not, thanks to YouTube, is a recording of the very first flight. It's amazing what all you can get on YouTube these days. It's about 30 seconds. We'll just watch this. As you can see, it's a pusher prop. They essentially took the IC engine and replaced it with a motor and batteries. I think it was like 8 minutes or something, or 12 minutes was the total flight time. And this was right outside Vienna, the airport called Wels. And that was the very first heavier than air electric flight, which was, I guess, recorded. Okay, then, believe it or not, after 73, a lot of time was, I wouldn't say wasted, but at least it was diverted from actual battery-powered all-electric aircraft to solar. Not that solar itself can do much. I mean, I've done some calculations, and solar really is not particularly good for flight, except for some novel things like the solar impulse, which took a couple of people up around the world. And this thing is a very interesting aircraft, the NASA Helios prototype. The only reason I highlight it here is because it is essentially just a flying wing. It is a huge, massive a wing made of solar cells, which powered these 14 tiny motors, and it reached a height of 100,000 feet. 100,000 feet has been in the news lately because of this Chinese balloon that was shot down in America last month. So here is a small clip of this thing taking its test flight over Hawaii. This was in 2001, I believe, 2003. I'm sorry, this was in 2003. And we'll just wait for this to end, which is now. And then, unfortunately, what happened was right after this flight in end of June, it crashed. Some also around Hawaii. So that was rather sad, but it reached 100,000 feet, which is not something that normal aircraft do. Is battery power? So the question then is, solar is certainly not something that is viable for any serious air travel. It's fine for reconnaissance, which is what the Helios was supposed to be. Reconnaissance aircraft, something that can stay up in the air forever, basically. But is it at all viable for battery power? So solar is out. Is battery power viable for flight, a serious flight? Let's do a little calculation. If you take a Boeing 747, it has 4 turbofans. Total, I've just made some calculations, back of the envelope calculations. I may be off by a little, but it's not by too much. So a total of, let's say, about 100 megawatts to climb, to take off and climb. If I make a calculation for 30-minute flight, the amount of energy that's needed in terms of the taking normal batteries, the best batteries today of about 220 watt-hour per kilogram as the specific density, energy, I'm sorry. If I look at that, an 80-minute flight with a 30-minute reserve, a 747 will be able to do it. And in fact, it will be able to carry pretty much the entire electric system, will pretty much take up the entire takeoff weight of this aircraft, which essentially means that they won't have any room for anybody else. Now, it would have room, but it won't have any leeway in terms of weight for any people, any payload at all. An 82-minute flight will not be possible. Battery power essentially is not commercially viable. If I take this entire big 747 and all I can carry are probably a few tons, it's not worth it. If I do the same thing for a narrow body, I could probably do a 70-minute flight and with no extra payload, but anything above that is out of the question. Again, these are my back of the envelope calculations. You can certainly argue with these and come up with your own. But the point I'm trying to make is battery power is not commercially viable for a large aircraft. It is fine for small aircraft, Part 23 aircraft, but not for a large aircraft. So what is, I guess, possible with today's technology? All electric battery power flight, far fewer than 10 passengers, in my opinion, maybe about 100 kilometers. There are claims, let's say by Lilium, that says that they can go 400 to 600 kilometers. I have to see it to believe it. Maybe about half an hour, because the FAA requires half an hour of reserve fuel for emergency. Hydrogen fuel, that's a really interesting prospect. There are things going on in that area, which I'll talk a little more about. That, I believe, can carry more. There have been some tests recently that seems to suggest that you can do better with fuel cell and hydrogen, but there are all kinds of other problems with hydrogen. We'll go into that recently. But hybrid electric was what I thought would be much better. But one of the companies that had a good idea, which was Zunum in Seattle, went belly up recently. So it's interesting. Performance is more efficient than conventional because of the sizing issues. In other words, you can make the gas turbine that actually drives the generator much smaller and much faster, and you can get more efficiencies that way. Other than that, there is really there's no braking efficiencies, there's no coasting efficiency, nothing like that in the aircraft. So in the air. So the 787 Boeing claims a 3% higher efficiency using more electric components. There are some studies, including from UTRC, which was the research center associated with UTC at that time. Now it's called RTRC. They did a study back in the day, and they claim that by some simulations and all, you can increase the efficiency by 20%. But I think the realistic estimates are much lower. And what I want to do next is go into some more details about the technology, etc. But Sushila has asked me to sort of stop at around this time. We are about half an hour into the talk. What I'll do is I'll hand it over to Dr. Padi, Radhakant Padi, and he can sort of moderate it now. I guess if you want to ask questions, you can ask questions, and then I'll come back after.
All right. Thank you, Dr. Ravi Rajamani. It was a fantastic overview of the history part of it. I mean, it was a lot. I think a lot of people won't know that probably about way back in 1883 this started all that. And it is rather surprising, but then this is the history part of it. And primarily because it was a balloon and probably lighter than air and things like that. So that actually helps. Maybe that is also happening now. A lot of people do actually think about exploring again, basically, right? So that lighter than air probably can be thought about.
Including for surveillance.
Right. Can answer your slide a little bit so that people can see you better, maybe. And so also you kind of nicely summarized about the very milestones that Austria flight was nice in 73, pretty close to my birth year, basically, that way. So then right now, whatever the current status is available, and also largely because of the weight and volume penalty, it's not possible. We all know that. But then battery technology also evolving. Maybe we'll cover that after this talk, probably. I mean, after this part of it. All right. So this is the time where you can actually take a couple of questions, if at all there. So anybody wants to pose a question, quickly, can you type it out, maybe? Okay, looks like there is nothing yet. Okay, so
I'm sure you'll have more questions after the tech portion.
After,
Being IIT, of course.
Maybe it takes a little bit of time to type it out, so maybe you can wait a little bit for the.
Yeah, we have time, I believe.
Right. So I'm just curious to know, how does it scale up to the drone part of it? Drones should be very much okay, right?
So yes, so drones, they have been able to, because mainly today the drones are not payload oriented. I mean, they really don't have to carry anything other than themselves and maybe one small camera or something. When you get to a level where the drones are carrying medical supplies or other things like that, now we are talking you're trying to balance the range against the payload. So, and it's not that easy to actually, I mean, in the little form factor that you have, you can, if you have nothing, if you have very, very light material, then yes, you can get some amount of range. But other than that, it's difficult to do anything serious with electric powered drones as well.
Also, just for information of the audience, maybe many of them probably know about it. Electric propulsion is also very curiously looked into in the space domain, space propulsion. So there, probably the ball game changes completely. You got very good specific impulse, which actually tells you a lot of efficiency. But because the mass itself is very low, the thrust itself is very low. So low thrust, kind of low thrust application. When you talk about long duration, low thrust, and all, there are actually interesting things coming up there as well. Would you like to spare some thought process on that, or not really?
So space is not something that I am an expert on, but the problem with space, of course, as you know, is all the materials for propulsion has to be carried along with you.
No, not only that, you don't have a medium. So even if you rotate your propeller very high speed, nothing there to kind of give you a propulsion.
That's right.
So they actually do a little bit of plasma generation. I mean, they take some gas and do a little bit of plasma and then expand that through some nozzle and all that. So,
but you still have to carry all that material with you. Even if you can use electricity to create the plasma, you still need that material with you. So that is an issue. I mean, that's one of the reasons why the ceiling for air-breathing aircraft is not that high. I mean, 60,000 for a flight aircraft, 70,000 maybe feet. 100,000 and all, there's no way you can take a, I mean, standard gas turbine up there. So,
Professor, you have a few questions now.
yes, we do.
Yeah.
So should I just read them out and answer them, or?
All right, and I will go one by one. So,
Okay, Radhakar.
yeah,
go
what
ahead.
is the view on the IITM developed two-seater?
I have seen a little about it. I don't know if they've actually finally developed it. I thought that was still a concept as far as I know, but we can go into that when.
There was a little.
I think it's called E-plane, right?
No, Ravi, there was a demo in the Aero India from them.
Oh, I see. Okay.
Here in Bangalore about.
Is this the E-plane that you're talking about?
Yeah, that was there.
Okay.
Two-seater plane.
Good. So I obviously have not caught up yet. So maybe the person who, maybe Raj can tell us more about it at the end.
Right. A second question, what is the scope of electric propulsion in India? Probably it's related to that.
It's related. What I can say is what I have seen and what I have known from what I've talked to people is mostly it's autonomous drone development. Not even autonomous. A lot of it is just remote control drone technology. There is some stuff from IIT Madras, especially, which seems to be doing well. There are at least two companies that I know in Bangalore that have developed drones. I've been associated with at least one of them. I don't know much in manned. Like I said, I mean, there are some concepts. If there is a two-seater, I would love to hear more about it. I believe this is the E-plane, but I may be wrong.
Next one, what is the possibility of electrical takeoff and a smaller engine for steady flight?
Yes, in fact, there are some hybrid solutions that do precisely that. I'll talk a little about that later. There's a company called Ampere, which is doing almost exactly what you suggest here.
All right. And the next one is, what are challenges for the materials needed to build the body of such machines, especially composites, perhaps?
Oh, it's all composite. I mean, there is just about every one of them that is being developed today is almost all composite. I mean, metal is going to be too heavy. So yes, there are lots of challenges. I mean, you sir know more about these challenges than I do about material challenges. But yes, it's pretty much all composite.
Yeah, there's quite a little bit of interesting question next. Somebody asked that while the plane is in flight, can the air drag come as additional source to generate the power? The battery power or solar power may be just required for takeoff, but other things can be dragged from the air power.
Yeah, I don't think the thermodynamics or aerodynamics work out.
All right, so that's probably the last one. So maybe the question we should discuss before going behind electrical propulsion is, for example, India has more than 60% of electricity from coal. If I use electrical plant, more than 60% of pollution remains the same. So instead, we should bring more renewable energy along with electrical propulsion. What's your thought on that?
I mean, you're saying the right thing, but I think the government has declared that what 50% or more will be renewable in 10 years. So I don't. Yeah, there's no doubt in my mind that is right. However, there have been a lot of studies that say that if you can produce, even if you do coal production, if you can sequester the carbon at the source where you have control over it, then in the long run, when you do the balance, it actually may not be a bad idea to produce even coal-based as long as you can sequester the CO2, etc. But I guess the business of it, the entire financial balance, I don't know if that which works out. There have been a lot of cradle-to-grave studies on energy, and this is a very well-studied topic. So all I can say is there's no simple answer to it.
All right, so probably we can take rest of the question after this break. It was a nice short break. You can continue your thing, and we'll come back to the questions wherever we left from.
Sure, no problem.
Thank you. Continue.
Okay, so let's go back to this. You can still see my presentation, correct?
Yeah, you can see it.
Yeah, nothing has changed. All right. Okay, so where are the technologies today and where do they need to be? This may be, all right, the motors and generators. Today, our specific power densities are in the range of 5 kilowatt per kilogram. There have been certain announcements about closer to 10 kilowatt per kilogram that Siemens has announced. Magni-X is, I think, in that range too. So according to some calculations, especially from NASA, NASA Glenn Research Center, they did some studies. They actually have an entire big lab in Sandusky called NEAT, which is testing out all these technologies. They claim that 13 kilowatt per kilogram and above is needed for viable electric flight. Power electronics, we are around that 13 kilowatt per kilogram densities, and we need something greater than 25. Ohio State, others have claimed that they can get there. Virginia Tech in the US, they're working on this as well. I'm now drawing a blank on the famous university in UK that's also very, very good at Sheffield. I don't know, maybe one of you knows. And they also claim that they have technologies at that range, 25 and above. So we're getting there. The biggest problem, of course, as all of you know, and you have even mentioned, is power storage. Lithium-ion secondary cells, which are rechargeable cells, have at most, and we are talking the most dangerous of them, the most risky of them, the most flammable of them, at about 230 watt-hour per kilogram. That's the specific energy. Elon Musk has said that if you can get something greater than 400, 500, that is the range where he thinks that electric propulsion can become viable for aircraft. And a lot of people have said that nothing less than 1,000 watt-hour per kilogram. So we have to go fourfold before this thing can become viable. If you take primary cells, in other words, those that are not rechargeable, aluminum air, for example, where you can take aluminum sheets, put them in this, and then take them out, then you can easily get 1,000. There are 4,000 watt-hour per kilogram densities. And Aviation, a company in Israel, originally actually had that idea, and probably, but it's a pain in the neck to recharge with actual sheets of aluminum rather than plugging it in. So there are all kinds of issues, operational as well as logistic issues of doing primary cells. But primary cells have much better energy densities than secondary cells. Now there are some other issues that one of the things that would be, I mean, you would certainly understand this, which is controls. Electric actuation is today not viable even for commercial aircraft today. The interesting thing is it's viable as long as you have redundancy so that the safety is intact. For primary surfaces, for control surfaces, an electric actuation is not certified today. It's not considered safe enough. So therefore, all commercial aircraft today have hydraulics as the basis of the motive power. So that's an issue that cannot be cannot be viable in electric aircraft. You have to have electric surfaces. So you have to have safe electric surfaces, and that requires some more work. Autonomy, again, we shouldn't confuse the two, but however, it is something that is seems to go along with this whole air taxi thing. And the reason for that is very obvious. It is going to be almost impossible to have a business case for air taxi, for what they call advanced air mobility systems, where you actually have to pay and carry a pilot. So either a remote controlled operator or an autonomous system is almost the only thing that will be viable from a business perspective. So autonomy kind of goes along with these small electric aircraft. And therefore, today, obviously, we don't have anything like what we need for a viable autonomous system. And certification, we'll talk a lot about that in the video, but that is a huge problem. A lot of the electric aircraft companies think that they can do this easily, but it is going to be difficult, especially with all the new technologies that they are bringing up. Now, Pipistrel, which is a company that has certified an electric aircraft. However, it's in the light sport category, which is almost experimental. So I wouldn't really call that certification. Certification is a complicated affair. It's not just the product, which is this central thing. Yes, aircraft engines, propellers, etc., have to be certified in and of themselves. That is, their design has to be certified. However, from design to actual reality is the processes, the manufacturing processes, the software development processes, even the airspace in which they operate, all that has to be certified and regulated. Not just that, there is a third aspect to it, which is the people and the company. In other words, the manufacturing, the operators, the aviators, the maintenance personnel, all of them have to be certified to be able to work on this thing. Airworthiness is not just how the design of the aircraft is. It is also what is known as continued airworthiness. How do you maintain it? A perfectly good aircraft can be spoiled very easily if you don't maintain it properly. So this is actually quite a complicated sort of three-pronged system that needs to be all work together for this to be viable. So different aspects of these challenges. There is obviously the systems on board, the energy storage, which we talked about, the power electronics. There are obviously power electronics on electronics today. There is energy storage on aircraft today. There is the storage on aircraft today. There's distribution on aircraft today. However, they're all at very, very low, relatively low voltages, less than 1,000 volts, and relatively low amperage. So the amount of power that's being transferred is mostly for surfaces, control surfaces, etc., and not for propulsion. And that's a huge deal. So there is a lot of work to be done in that area, the entire power generation, power storage, power distribution within the aircraft. Is it going to be DC power? Is it going to be AC power? Even those things haven't been decided. And typically what people are saying is it might be AC power for the actual motors. In other words, you will have inverters. However, you'll have DC power for the transmission, because that is and very, very high voltage and very relatively low current, so that you can actually have manageable wire sizes, etc. There are, along with all this, there is novel failure mechanisms. Everything about certification is how things fail and how do you recover from failure, or how do you mitigate that failure. That's really all new in electric aircraft. Also, crash response. What happens to the aircraft itself if it crashes? We are talking maybe 1,000, 2,000 volts. We are talking 600 amps. We are talking systems that are extremely high power. I mean, we got megawatts of power just waiting to explode if this thing crashes. How is and on the ground, how are emergency response teams going to work? How is the second responders going to come? How are the medical personnel going to come in there and retrieve the injured? All kinds of issues associated with this that people really have not thought about. In fact, they haven't even thought about this. They're starting to think about it in the automotive world. Aircraft world is another level altogether. So that's an issue. Obviously, the charging is an issue. As those of you who drive electric cars know, there are multiple charging options even in electricity in cars and trucks. We hope that we don't make the same mistakes in the aircraft world. Let's make sure that we standardize on the charging infrastructure before we get too deep into this. There are a couple of competing standards already in the aircraft world. One is the GBT, which is the Chinese version, and the other is the CCS, which is the European version. Both are kind of competing. Different companies have chosen different charging standards. I work a lot with SAE to develop standards, and we are trying to develop a standard for below 1 megawatt and above 1 megawatt charging. There is a lot of work yet to be done. It is not yet been decided. We're developing standards right now. The electric infrastructure, if we go massively into an electric propulsion, including that for trucks and aircraft, how can the existing grid actually be able to sustain it? And also there was that question about coal. I mean, renewable energy. It's a lot. It's quite a mess. We talked about emerging this airspace management. If they have so many aircraft, manned aircraft, air taxis, urban air mobility, drones, your Amazon dropping off packages using little drones, can that all be sustainable in the airspace? The sky is vast, but can it all work without them running into each other? There's all kinds of issues, and I think NASA, especially Ames Research Center, has a huge program trying to develop the next generation air traffic management system. Some other key technology issues, power transmission. I talked a little about this involving the voltages and currents. The NEAT facility in Sandusky, Ohio, run by Ames Glenn Research Center at NASA, is trying to develop what they call a Ironbird. They're actually putting together an entire electric equivalent of a high power megawatt aircraft system, trying to get this to work and test it out. Superconductivity. There's all kinds of issues related to superconductivity, which you need both for if you're trying to do hydrogen propulsion as hydrogen gas as the means of propulsion, or trying to get more efficient power electronics and power transmission. So there is issues related to superconductivity. There is research going on in that area. Believe it or not, ice protection, mundane things like ice protection could be a big drain on electricity. So you need to add to that. Now, it's not that big a problem if you're not flying that high. However, if you start flying high in colder weather, you got issues. We talked about the supply and the grid issues and the crash procedure. So there are many such major and minor issues to be dealt with. I will now sort of go through some of the major developments that have come about, mainly after the book was written, etc. These are all brand new. I talked about the light sport aircraft category. Pipistrel, this was certified in 2020. This is not yet available in the US or anywhere else in the world. China it is. The FAA does not currently allow electric propulsion for LSA. That is changing, but that's something that is coming. But this has the honor of being the first electric aircraft to be certified. It uses, by the way, the GBT modified GBT version for charging. Aviation Alice, this was last year they did the first flight. This is an interesting aircraft. This is the Israeli aircraft. Initially they were going to use primary batteries for this. Now it actually uses secondary batteries. However, if you notice, 60% of the takeoff weight is actually just batteries. So this is, as the CEO Omar actually talked about this. We were talking once. I asked him. He says this is an aircraft that is a battery, and an aircraft is built around it. So that is the only way they can get the range that they claim. It's supposed to carry 9 passengers today. I think it's still being tested. There are a couple of real interesting companies in America. Joby is one, which has really made a huge, and this is actually listed on the stock market. This made a big flash a couple of years ago. According to them, they just completed the stage 2 of the certification process. It's supposed to carry 4 passengers, and this stage 2 means that the means of compliance for the Part 23 certification has been certified by the FAA. This uses, like I was telling you, the automotive batteries, the nickel magnesium manganese cobalt oxide, which is much more, I guess, unsafe. If you look at it, if you penetrate it, it'll explode, as opposed to iron phosphate, lithium iron phosphate, LFP, which are much safer. However, they don't have the energy density that the NMC has. So that's an issue. And so we talked about how quiet they are. I guess Ashok said that, and it claims to be 100 times quieter than a helicopter in takeoff. So this is one of their big selling points. The Archer is another big. It was 2018, I think, was when this company started, and it's doing pretty well according to that website. It is leading the pack. It did a partnership with Stellantis, which is the old Chrysler, Fiat, Peugeot company, and they are going to actually manufacture the aircraft, which is really interesting, because if anybody knows how to manufacture a vehicle, it is a car company. So it really, that's actually a very neat deal for these guys. Now, somebody mentioned hybrid air in one of the questions. And this is truly a hybrid aircraft. What they did was they took a Cessna Skymaster, which has two, a pusher and a tractor propeller engine. They took the front engine and replaced it with a motor. And essentially what they're trying to do is figure out if this can be something that can be more efficient than a two IC engine aircraft, and it can be used for short flights, such as island hopping in Hawaii or in Scotland. So those are the two things that they are trying to market. This is a very interesting company in California. I've met many of the principals there, and I mean, they're doing a good job. And they're not that concerned about certification, because it is a certified airframe that they're using, and all they're doing is replacing. The one of the motors. And I did some research. I know a few of them. I don't know all of them. E-plane, I believe, is the one you're talking about, but you can certainly correct me if I'm wrong. That's the IIT startup that is developing a two-seater. Vinita Aero Mobility, again from Chennai, that's this one. Again, this seems to be just a concept. I thought this was just a concept as well, but looks like they have demonstrated it at in Bangalore. UCAL, I've worked with folks at UCAL. They are developing a drone for agricultural use. And then General Aeronautics, which I think a lot of you are familiar with in Bangalore, Adani has now bought a controlling, or at least a majority stake in it. And they are also developing systems for agriculture, drones. And then Bonvi, I just heard about this. This is another company, again, an IIT inspired startup. They are in Odisha, and I guess they're based in Bangalore. I couldn't figure out really. But yes, it doesn't look like a lot of work is going on in the manned field, but a lot of companies are developing drones. And the only reason I mentioned these, at least I know two of them personally. Okay, so there was one question, I guess, that has come up time and again. Is hydrogen the answer to the range issue and viability issue of the business viability of electric aircraft? So I'm talking really not about hydrogen being burnt in a gas turbine, which is another way you can use hydrogen. I'm talking about hydrogen being used in a fuel cell, which is sort of the more popular way, even for automotive systems. I heard last year talk by Donald Slattery, the CEO of Avalon, which is, I think, the second largest leasing company in the world today, based in Ireland. According to him, and according to his brother, who was at that time the chairman of the president of GE Aviation, hydrogen is the answer to the future of aviation. Now, I don't personally believe that necessarily. However, there are many good things about hydrogen. And the biggest thing about hydrogen is that it's got the highest specific energy from a mass perspective. In other words, it's 3 times better than jet fuel. However, it's 3 times or more worse than jet fuel when it comes to specific energy based on volume. In other words, you need a hell of a lot of volume to actually carry the hydrogen around to power it for any amount of range. Now, there was a cartoon, I remember, and I couldn't find it, otherwise I would have shown it, that if you want to power a 737 with hydrogen, or a A320, a single aisle with hydrogen, you need an umbilical cord and another 320 following it just to supply it with the hydrogen needed for its typical route. So there is that problem. The cost and safety issues are also enormous. Storing and carrying hydrogen is not an easy task. What about the environmental impact of hydrogen? Yes, burning it gives you nothing but water, agreed. However, making it, producing hydrogen is not that easy unless you do it in a green way, and that's not that easy either. I know India is trying to do that a lot. I mean, there are a lot of people are developing this, and including the UK. And including the island hopping that I talked about, they are developing fairly quite a rigorous, quite a advanced way of doing green hydrogen there, and that might be an answer. We have still got to see that. However, there are, and maybe because of that, maybe there are there's a lot of incentive from the DOE and others to develop hydrogen infrastructure in the US. In Europe especially in the North Sea area, they're doing a lot in that. And I believe I heard even India is doing a lot. I don't know much about it. But there are 3 or 4 companies in the world that are trying to develop this hydrogen-based aircraft. Universal Hydrogen, which I want to point out because it was the CTO, the guy who started this was the ex-CTO of UTC, Paul Aramenko. He was a DARPA guy. I knew him when I was working a DARPA program many years back. He developed just a way of storing gaseous hydrogen, but now I think they've gone on to actually become more vertically integrated. They're actually working with Magnex to develop their motors. They're working with plug power for the fuel cell, and they have got a Dash 8 that they've now got permission to actually fly later this year. Zero Avia, which is modified the Dornier 228 with one of the engines, they have changed it to a hydrogen powered. They are they're advanced in that. H2 Fly, which is a DLR spin-off from Germany. It's the research labs, and they have modified the Pipistrel Taurus. It's the one with two, I guess, fuselages and a center engine, and they've converted that to a hydrogen fuel cell vehicle. And then there is a company that a local company here that I've been involved with that is trying to develop a hydrogen-based concept vehicle. So Zero Avia, I talked about this. First flight was on just earlier this year in the UK. They were a California company, but UK has been giving them some incentives, so they moved there. And it's trying to develop 2.5 megawatt. They've done about 600 kilowatt system. They're trying to develop a 2.5 megawatt system. So that's a good thing. And then you have this Luftcar concept only. Sorry, it's just it's an interesting concept. What this person who's the founder of this company, he's actually an Indian, Sant Satya, who's trying to develop a system that is hydrogen based, but that is not as important as his concept of trying to solve the last mile problem. What he has is this hybrid vehicle that actually can land, and the little thing takes off, and you have this the structure that actually does the vehicle separate from the actual payload, which can carrying vehicle that can go on the ground as well. So that's an interesting problem, and he is based locally in Connecticut. Okay, but we talked a little about the business viability of this thing. So there was this article by my friend Kevin Michaels late last year, which says the opinion there will be blood dissecting the eVTOL business model. He basically said that it's going to be impossible to do. It's really, really very difficult. His bottom line was he doesn't know what these air taxi companies were smoking. So I did a little back of the envelope calculation. If you look at the capital costs, etc., you can actually do some kind of a calculation to figure out if this whole thing will work. I don't want to belabor you with the details. I'll be more than happy to share the spreadsheet with anybody. You can work with it. If you have 4 passengers with a pilot, actually I did put in a pilot in this, you will barely break even with a fleet of 20 doing 10 hours per day, 300 days a year of flying. And but with 3 passengers, you will go under very quickly. So you will, it's about $1,000, about $800,000 a year of revenue for about $800,000 of a year of expenses. With $600,000, you aren't going to make any money. So that was the bottom line. I kind of agree with what Kevin came up with. It's going to be tough. However, there are all kinds of new deals in this area. I mean, every major airline has signed some kind of a deal. I think they just don't want to, it's one of those things you don't want to miss out on you never know what it is. So what for them is not that much money they are willing to shell out to get a stake in the future. So there are several companies racing to certification. I did mention that Joby, Lilium, Archer, EHang has already claimed that it is certified, but last year they said, before that they claimed they had certification. Now they say that they have a plan for certification that's approved. It is not really clear what they're doing. Whisk, and again, they thanks to Boeing's investment, I mean, they are, I think, doing much better than they were. They were one of the earliest to do this, and they were actually based in New Zealand, and they were trying to get it certified there. I have spoken to the New Zealand folks, the authorities there, and they said that they were doing pretty well. This was 3 years back, sorry. So I'm hopeful that with Boeing's backing, they'll do well. This is Whisk. Beta has a lot of support from the United States Air Force. They are in Plattsburgh, upstate New York. They're doing some testing, and they're based in Vermont, a very unlikely place for an aircraft company. And Volocopter, I couldn't get any information about their certification plans. Anyway, so what is the bottom line? I think there's no technical imperative for doing this. The financial case, as we saw, is not that strong. The logistics issues are really profound. The environmental case obviously can be made, but again, you have to look at the cradle to graves, and it's not clear that it's really positive entirely, but I believe it is to a large extent. I think it's more the sign of the times. It's just the zeitgeist, I can say. It's a sign of our times rather than any real need for doing this. And it's a lot of money that Silicon Valley billionaires have, and they want to do something new, and this is their next new thing. So maybe that's one of the incentives. Maybe I'm wrong. I don't know. Anyway, at this point, I will stop. I believe I'm just a little over what I was allocated, and I will open it up for questions.
All right. Thank you again, Ravi. Very nice summary of everything that's happening around the world. I think you've got a lot of person for collecting all the information as and when it happens. And also probably you do all your own calculations to kind of conclusively claim certain things, which requires a lot of person for doing all this basically.
They may all be wrong though.
Not really, not necessarily.
It's all kinds of assumptions. You can make anything work anyway. But I think I've made some reasonable assumptions.
Good. So this presentation is anyway will be available. I think it's getting recorded. So for those, I mean,
we can get some version of it to you.
All right. So we'll start the question answer where we stopped. The next question that was already typed previously is something like, what will be the effect of pressure at high altitudes on the electric aircraft battery?
I don't know anybody has talked about that effect. I don't think it matters. Today you have lithium-ion batteries working in non-pressurized cabins, so it shouldn't be a problem.
All right, we'll go to the next.
At least I don't know of any problem. There are other problems, but not pressurization.
What cost-saving percent can electric propulsion provide in commercial aviation, for example, helicopters? Since the number of passengers is less than 10, does it have any cost saving?
I don't see. I mean, again, it's very, very difficult to compare with a normal fossil fuel engine. Those things are so mature now; they're very cheap. So, yeah, I mean, it's going to be difficult to claim that you're going to get some kind of a cost savings.
All right. So the next one is nuclear-powered submarine and ships are really long back. They're already there. So is it possible to have small nuclear-powered commercial aircraft in near future? I think the certificate is a challenge, but is there any development in nuclear-powered commercial aircraft for your knowledge? I mean, to your knowledge.
No. I don't think anybody is going to do that. It's just way too dangerous.
And can you use catapult-like in the aircraft carrier for takeoff and smaller electric system for flight?
Yes, I mean, they have done that for drones. That is, I mean, it's fairly standard in some, at least the fixed wing drones, and especially for military reconnaissance drones. I mean, you aren't going to catapult a helicopter. That makes no sense. But yes, fixed wing, it's done all the time for small aircraft.
All right. Next one, technology front, electrical propulsion airplanes are less complex than conventional aircraft having fuel engines. We can see a number of players emerging all over the world. Earlier, we had a few players from developed countries. What is your thought on technology complexity while using electrical propulsion?
Yeah, I completely agree with you. Electrical propulsion, because you separate the generation or storage of energy from the use of energy, and the only thing linking the two is a wire, it makes life much easier. And in fact, so I kind of want to modify one of my answers from earlier. Because of that, it actually in some areas could be cheaper to make electric propulsion vehicles because of this. You can use standard motors, you can use standard electronic systems, etc., to get that, and you can increase safety by using what is known as distribution electric power, so DEP. So you can actually have redundancy. For example, the Volocopter has 18 little propellers. The Lilium has 24. And we saw the one with the 14. So there are all kinds of Archer has 12. So that is one way you can increase safety by making these things redundant. And the fact that you can actually take power from the generator or the source to individual thing, and you can control them individually, it makes a big difference. Yes, it is easier.
Thank you very much. I think we are done with the question answers. Now, no more questions in the question answer session. So I will now hand it over to Mr. Ashok Kamath.
I do want to mention that control becomes more difficult because you have to coordinate all these various aircraft. So
power management control, not necessarily the flight control.
No. Flight controls becomes very difficult in these cases because what they do is when you have parallel propulsors, you get rid of the control surfaces. So you have to do differential control to actually get all the yaw and pitch and etc. So that becomes a bit of a difficult thing to do.
All right, Dr. Kamath, maybe? Ashok Kamath.
Thank you very much. I think today was absolutely fascinating, a topic that was completely different from what we've been, going through all these, through the last 60 webinars. The whole idea that there may be a bunch of things flying overhead as well as on the road in Bangalore gives me the heebie-jeebies. I can't digest it. But yeah, today's just a few takeaways. Today's talk was focused on manned flights using electric propulsion. And starting October 1883, mankind has been trying to get an electric aircraft up there. 90 years later, in the October of 1973, the first heavier than air flight took off at Wells and landed safely. From then to now, we have seen a lot of development, and today there is a rush by many companies to get certifications and so on. So there is much that has been happening. I felt today we got a great understanding of the history of not just electric propulsion in aircraft, but also the various technologies that are involved. And we started by looking at challenges to adopting all of this with, looking at aspects such as the risk aversion of the aviation industry, the challenges that new technologies bring in, and what is all of that going to imply. The electric grid, air traffic management, and of course, passengers and their attitude towards sitting in something like an electric aircraft. So we looked at various types of what are the technologies that are going to be required and where we are and where we need to be. We looked at motors, generators, power electronics, and so on. But power storage, Ravi reminded us, is probably the most difficult issue. And he did spend a lot of time talking about the different options. Hydrogen fuel cell came up as one of the good options, but if you have to run and if you have to get an A320 to fly, you need an A320 to carry the fuel cells for it. So, questionable. So the prediction is not earlier than 2030 are we going to see something really tangible happening in this whole space. He talked us through certification and the complexity of that whole issue. Systems on board as well as systems on the ground, everything needs to fall in place before we can really have something that is viable technically to just get stuff off the ground. And then we looked at the commercial viability, and Ravi's prediction or Ravi's point of view is that you need at least 4 packs with a pilot and 20 aircraft in the fleet flying for at least 10 hours a day for it to be just a break even, for the whole enterprise to break even. But yet there are a lot of programs going on around the world, a lot of investments taking place. And we looked at some of the important or the leaders in the pack. So Joby, S4, the Archer makers, Midnight, Ampere, Eel, and so on. And then he also talked to us about the local startups. And it's interesting that pretty much all of the companies in that list are either in Chennai or Bangalore. And so, yeah, and it's a, at the end of the day, is this really required at this point of time? Is there a real need for electric propulsion in aircraft? Probably not, given that there is no technical imperative and still a lot of question marks around it. Financially or logistically, if you look at it, there are a lot of challenges. Environmental issues is still iffy, yes and no. So it's probably, so Ravi concluded by saying that it's probably a sign of our times and our, the availability of a lot of things and minds that just want to do something new and something different. But, we are hopeful that something good will come out of all this, if not to put, manned aircraft into the air, for something else, that some of these technologies might result in, some of this work might result in an impact on something else somewhere in our lives and make the world a better place. So with this, I want to say thank you to our audience for being here and for participating with all your questions. Professor Padi, it was particularly very nice that we had you here today, and the discussions that you could bring in to today's webinar were really interesting. So thank you for accepting, and thank you for being here. Ravi, thanks very much. We know that we woke you up early in the morning, and thank you for being here, and thank you for your time today.
Not a problem. My pleasure. Thanks, Radhakant and Sushila, and Ashok, who doesn't want to show himself anymore.
Yes, sir.
And goes on mute.
Yeah.
Very good.
Thanks so much, Ravi and Professor Padi.
It was nice.